Hi everyone. This video is going to talk about IPv6, the basic IPv6 address structure, and also focus on the neighbor discovery protocols, ICMPv6 that covers neighbor solicitation and neighbor advertisement, which are the two protocol used to replace those ARP request and ARP response, and also neighbor did router advertisement and router solicitation and route redirect. Those are the five protocol from 133 to 137 covered under the name of the neighbor discovery. Okay, and in the IPv6 folder for the corresponding courses, if you click that, you're going to see a few files here. Depends on the course you're taking. IPv6, this is just a highlight. We're going to go through the concept, and then this is focus on the neighbor discovery protocol 133 to 137 was the neighbor discovery protocol we just mentioned. We're going to go into the detail, and we are going to also take a look at the router advertisement flag of the M flag, O flag, mainly, and the significance of that. And another document here is to show the well-known multicast IPv6 address. And then those are the two capture file that we can take a look at. What do we mean by the multicast address, and how do we get those multicast address, and how does it work? And then after you look at the capture file and get comfortable with the concept, I'll show you how to actually capture with the real VMware image. And you can see the file, the neighbor solicitation and neighbor advertisement communication between your computer and the neighbor, and also see the routers communicating with the workstation for the router solicitation and also the router advertisement. So you click this one and you will download it. And we were going to see this particular document that we will talk about. All right. So for this document, the beginning on the top, this is the general introduction. You're going to take a look at, read it yourself in that. As a general introduction. We'll go through those highlights. Some of those net is no longer necessary, is not available, so we do not worry about net anymore in the v6. And you have to understand what is the stateless and stateful. Okay, stateless meaning that you actually got a router advertisement and you got a network prefix from it. For instance, if you are in the IPv4 environment, you knew that the prefix of your network is 10.10.10.0/24, then you will use 10.10.10 as the network portion and self-generate your host ID. And IPv6 the same way. You are looking at the network portion, and then you will generate it yourself. That's called stateless. And usually when the M flag, we will go into the detail, the management flag, if it's 0, then you will go for the stateless. If the management flag is on, meaning that equals 1, we will take a look at the packet later, then you will get a stateful, meaning that if there's a DHCP server there, then you will get a DHCP server assigned the stateful address. If M is 0, then you won't even get a stateful DHCP address from the DHCP server, even if you have a DHCP server there. So this is what this those statements is talking about. All right. Now, here is the neighbor discovery. Now we talk about it's ICMPv6, and it replaced the broadcast ARP. Okay, so the in theory, we say IPv6 doesn't have broadcast. However, there is one of those broadcast multicast address, and it's the local network O nodes. For instance, this router advertisement, it has to advertise it to all nodes, everyone. So that means everyone, when they receive that, when you are going to subscribe it to the multicast for the all nodes, well, which to me, it's like a broadcast, okay? We will go into the detail of that later. Okay, so IPv6 is 128 bits, and it's between the link layer, layer 2 is still the same, and for the transport layer remains the same. So this is the layer 3 that's been changed. So that's an important concept. IPv6 didn't actually redefine the whole TCP/IP protocol suite. It just updated the IP layer. Okay, so that's a very important concept. And remember, in Ethernet layer 2, when you capture a frame, then you're going to see, hey, it's A6DD. And let me show you what I mean by that. Okay, so I open the file in your folder, the IPv6 NSNA capture, ICMP. So for this particular file, we can see that, hey, I have a neighbor solicitation and then a ping and then neighbor solicitation and the advertisement again. But remember, I said I'm going to show you the type field of layer 2. So let's take a look at layer 2 here. And if you click that, you can see the whole thing has been highlighted down below. And you can see here for the IPv6, it's A6DD. So A6DD identify what's coming up. It's IPv6 coming up. Okay, so this is what it means by 86. Actually, it's a hex number A6DD. This is in the layer 2 type field. And destination MAC address, source MAC address remains the same. And then layer 3, of course, between 46 to 1500 byte remains the same in there. Right? So IPv6, we know that it has so many addresses. We'll never use it up. That's that's a general consensus. So we have actually 128 bit, and writing that so long is so hard to understand, to read. So therefore, we group them into a hex number. So hex number is 4-bit. So this is 16-bit per group, and we have 8 groups. Therefore, we got 128 bits. Or we can say 16-bit each group. Each group has 4 of the hex number. So 2001, and that's supposed to be talk about as 2001, even though it's easier to understand to talk about the IPv6 address. So I'm going to use that, and you just knew that I mean it's a hex number. So hex number 2001, of course, is different than the decimal 2001. Okay, so we see this is the general format of IPv6 address, and there are some conventions here we need to go through. There's a double colon notation here, that if you have a few of those zeros in between, for instance, as I have about 6 zeros in between, now we can zip it up and use 2, abbreviated to 2 of the colon here. So the colon will be expanded up, filled with all zeros in between the front and the back. And it will fill it all the way to 128 bits. So you know that you can only have 1 colon in one of those representations. If you have a colon in the front and a colon in the back, then you don't know this colon have what, 16 0, 32 0, and how about the other one? We don't know. So therefore, you can only have 1 double colon. Okay. And again, 0030 equals 30. You can abbreviate that. But the 0, you cannot take it off at the end here. So 30 is not the same as 3 here. All right. So this one, it will be abbreviated to FF02 colon 30 colon 5. Okay. Now, this is a note that we already went through, that you can only have 1 of those double colon. And the prefix, we mean subnet prefix. So that means the subnetwork. And as you can see, in the IPv4, we used to say, oh, okay, it's a 10.10.10.0/24. That means the first 24 bit is a network. And 0 because it's all hosts and the smallest host. Therefore, that represents a network. So we can say 10.10.10.0/24. That means it's a similar to a class C subnetting. And here's the same way. We use 48-bit. So this is 16-bit. And D3 is 00D3 is also 16, so that's 32-bit. 32-bit got another 12 bits of the 0. So the first 48-bit, it will be the network. Okay, and if it's /64, and here is 16, 16, 16, 16. So that's 64-bit. So this is the network. And colon means that fill it with all the zeros. Therefore, it's like equivalence of the 10.10.10.0. So this is the notation to represent an IPv6 address prefix, the network or subnet. So we're going to talk about the unicast, and mainly we're going to focus on the multicast and talk about the naval discovery. This is a global unicast. We know that's a basic IPv6 standard format, and there's a local address which is similar to the 169.254 IPv4 link local address, and the site local is similar to the private address of IPv4, like 10.0.0.0, 172.16.0.0, and those 192.168.0.0 network. And things like that. Those are the site local. Site local has been depleted in IPv6, so we don't even want to talk about that. And there are some of the special addresses too. We'll look into it. All right, so this is the format of some of those definitions. I'm going to leave that to you. It only have very small space that has been allocated and used. So you're going to read through that yourself. We're going to talk about the link local address a lot. So it's equivalent to that prefix. All right, so link local addresses such as it starts with FEA0. Okay, so it's usually a /10. The first 10 bit is like that. And of course, a link local address, it will fill it with all the zeros. So therefore, it's FEA0:/64. That's basically the format that we will use to assign the link local address if we want to assign it. And in my previous exercise that we actually gave FEA0::10 to the ASAV firewall security appliances to do the exercises of IPv6. We actually assign FEA0::10 and /64 as the syntax in the Cisco device. Okay, so that's the format of the link local address. Site local, we're going to skip it. And of course, the zone ID, you will read through that. And you do an IP config the same way, and you can see both IPv4 and v6 address. Now we're going to focus on the unique local address in here. Let's continue on with, okay, so let's talk about the unspecified address. Unspecified address is like : okay? So it's indicate that when there is no address, and sometimes we use that in a 0.0.0.0 as it's the equivalence of the IPv4 on that, such as has been described in here. And then the other one is similar to the 127.0.0.1, so it's a loopback. But this is more sleek, and you only use one address to represent a loopback. And by the way, the loopback, as the name implies, when you ping your loopback, nothing goes out because it's looping back. So nothing, if you use a Wireshark to capture it, you're not going to see any packet if you're pinging the loopback address. And we're going to skip the comparable address, and you can read it yourself. We're going to focus on the multicast IPv6 address. And it started with the FF for the multicast address. And of course, it cannot be the source address. It usually will be the destination, so you can do a multicast out. You usually will put your unicast address as the sender, okay? All right. So then let's talk about the scope of the multicast address in here. The one means that interface local. Interface meaning that it's inside the interface itself. We usually don't deal with that. Usually the two is the one that we will deal all the time. That's a link local scope. That means it's like it's the 169.254 equivalent of IPv4, and this is the local. The format of FEA0 is similar to the global unicast IPv6, except that's only locally significant. Just like a MAC address in a layer 2 is only locally significant because every network, they can use the same link local address. So therefore, it's only locally meaningful. And 5, we don't use it. Basically, site local, we deplete it with that. And then, for example, if we use the FF02::2, right, which is a router multicast address. So if we, at this point, we probably should take a look at the other document. So the well-known IPv6 multicast address, the first two lines listed one of the very important multicast address. And this mainly you will see that in router, you will capture it, and I will show you the router solicitation address and router advertisement address. And FF02::1 means that it's all nodes on the local network. It sounds to me like it's a broadcast type of deal. And so when router wanted to do an advertisement, it's going to send it to this FF02::1 as its destination, the multicast address. And then when a station wanted to soliciting a router, say, hey, are there any router on the local network? Then you send it to all routers. All the routers, they will process the request. They will respond to the multicast address of FF02::2. So let me also show you the router advertisement packet at its time, so we can have a good idea of what that is, and then later on you will capture it yourself. Okay, so this is the capture of the router solicitation and also the router advertisement. So if we take a look at the router solicitation here, and you can tell in here, first, this is a layer 3 multicast, and the destination from this particular host, this is the local host, is link local address, and it try to solicitate and try to find a default gateway or a router. Then it will put down the destination of FF02::2, which means that it's all the router on the local area network that we wanted to get a response from. So the router, if you're a router, you are going to respond it to not only your own IP address, v6, but also the FF02::2 address. And there's a rule for this for the link between the MAC address multicast and the multicast of the IPv6. The rule is that it starts with the 33:33, and then the rest of the 32-bit address here, it's a copy. So, and you can see that this is actually this is the MAC address. So you knew that MAC address total 48-bit minus this 4444 minus the 16. So you have actually, this is actually 8-bit together, right? 8 times 4. So this is 32-bit. And this 32-bit you copy from here. The multicast, the last 32-bit will be copied into the broadcast address. So that is what your router will subscribe. Not only the router will have a MAC address, but it will also subscribe to the service of a multicast MAC address of 3333 and then colon 0 colon colon and this MAC address. So this both multicast in your solicitation. You are doing multicast. You want to talk to all the router, and then you also use this predefined MAC address for the router solicitation. And the router is going to respond to you with a router advertisement. And the router advertisement, in this case, it's going to advertise it back to all of the nodes. And that's why they use FF02 colon colon 1 in here. So that means all nodes on the local area network. So everyone will subscribe to the 333300000001 on this MAC address. So when this packet has been sent to the switch, it's going to forward it to every single one, and you will receive your multicast address. And so that the destination here now, it is actually from the router. And you can see this is the router's MAC address, and it put into the destination of FF02 colon colon 1. And that's a multicast IPv6. So that everyone on the node, they will process this FF02 colon colon 1, and they will record the MAC address of this router, which is the Cisco 885A92. And after that, then they will have the MAC address of the default gateway, and then they can send the packet to the default gateway and go out to the internet. So that's the communication. It's very similar to the ARP request and response, but it's now using multicast on the router solicitation and do the router advertisement. Okay, so you be aware that in the solicitation, you just use the multicast address of the 33, and then use the 02 for all routers. And then destination, of course, is all routers, FF02 colon colon 2. And the response is actually to all nodes on the network, because you are the default gateway. So you send it out with, of course, if it's colon colon 1, then the MAC address will be, the multicast address will be 3333, and then 32-bit 000 all the way with a 01. So that is the multicast on that. All right, now I'm putting this aside, and we continue on to go this. So we're going to focus on that FF02 colon 1, that's all nodes multicast, and FF02 colon 2, and that's all routers that I just showed you over there. And you can visit the IANA link to see all the multicast address. And you can visit that. And now there is a solicited node address, which means that in the IPv6, such as neighbor solicitation, then the rule is this: you're going to use FF02 colon 1, but you're not going to bother all the nodes. Okay, you don't want to disturb. So you see, which would disturb all the IPv6, which we don't want it. Okay, therefore we are going to use FF02 colon colon 1. Then there's no improvement. We're just doing ARP broadcast all the time now. So we are going to use that prefix here, and the last byte is going to be FF here. So total up to 104 bits, and leave the last 24 bit here. We're going to have a 24-bit here, okay, of your IP address, and you're going to put it there as your multicast for the neighbor solicitation address, a multicast address. So let's take a look at it. Now, let's say this is the address of our local host, right? And the last 24-bit, it will be, this is a 16. You can see this 16-bit, all right? And plus the 8 So that's a 24-bit. So, so it should go from here all the way to, let me stop at the 2 here. So this is 24-bit. So therefore, your multicast address will be here, ff02 colon 1 colon ff. So here is all the way 104-bit. And then the last 24-bit of the IP, you will be put it in here and make it your IPv6 multicast address, the solicited no multicast. So you will also, your system not only will respond to directly to this particular IP address request as a destination, but also it will respond to the ff02 colon 1 ff289c58 as your as the destination. So this is the multicast address. And you will know that here, um, this is actually the layer 3 multicast address, and that's 24-bit. And all the way to here, this is 32-bit. And from the rule that I just told you, the last 32-bit of the IP multicast, it will be stick it after the 3333 multicast in the MAC address, multicast address. So this multicast MAC address will be 33 colon 33 colon ff289c58. Okay, so if we take a look at the real example here, it will make it more clear. Remember the rule that your IPv4, IPv6 in the layer 3 IPv6 multicast address, the last 32-bit, it will be put into after the 33 colon 33 as the multicast address in the MAC. Okay, so your system will also subscribe, in addition to your MAC address, you will subscribe to that particular MAC address, multicast address, and it's related to your IPv6. And it's the design of IPv6. And that is a mechanism where we can eliminate using the broadcast without having bothered to using the broadcast for everyone, okay? Because the link of this V6, IPv6 layer 3 and the layer 2 relationship. And this is similar to the IPv4. We have the similar relationship on that. Okay, so let's take a look at the Wireshark information on the neighbor discovery. So let's look at the solicited address here. The neighbor solicitation. So if we try to ping from 2001 colon 10 colon 1, and we try to ping ICMP here, we try to ping, let me just bring this out a little bit. We try to ping 2001 from the 1 to ping 1010 or the other way around, whatever that is. Basically, you will 2001 colon 1 is going to send out a multicast, and you can take a look at this multicast address. Let me open it up. All right, so you see, when you want to ping 2001 colon 10 colon 1, you want to ping 2001 10 colon 10. So what you will do is you are going to use a multicast address in your neighbor solicitation using FF02, right? And colon 1 with the old nodes, but we don't want to disturb everyone. So we use a 104-bit with colon FF here, all the way to FF. This is actually the 104-bit. And then the last 24-bit of your IP, which is, well, filled in with all the zeros in the front and the 10 at the end. So what? This is the multicast address of the 2001 colon 10 colon 10. So that's the multicast address. So this multicast address in here, and we mentioned that there's a relationship of using this multicast into the layer 2. Layer 2 is 3333 multicast. And then the 32-bit here will be the multicast copy from the multicast of the IPv6. So this IPv6, you can see that the last 32-bit is FF00, and then 00 in the front of the 10. So this is the multicast address for this neighbor solicitation. and it has a, so when the 2001:10:1 want to talk to the colon 10, when one want to talk to 10, it's going to send out a multicast destination IPv6 multicast here with the multicast MAC address here. So layer 2, layer 3, both multicast. And the switch will not bother anyone but the one who subscribed with this 00010. So this is the subscribed address of the host 2001:10:10, and then it's going to respond it back. And here it's going to be a unicast. Say I am here, neighbor advertisement. Hey, I am 2001:10:10. Colon 10 here. I'm here. This is my MAC address. And after that, the 2001:10:1, you can ping that because now you have both the source and destination MAC address now. Okay, so that is the. So I just show you two different type of the multicast address in the layer 2. One of them is 3333, and then with the FF, and then with the actually, the total is the 32-bit of this multicast address, but this one start with the 3333FF, okay, noticeably. And the other one, the other Wireshark is the router advertisement, and you can see that in here. And you will see that in the router advertisement here, you're going to see 3333 and with the 0000001. And the difference is because the other one is using solicitation with the FF up to the 104-bit and then the 24-bit of the IP address. And here, because the IP address in here doesn't have the FF and then with the last 24-bit address, this is actually old node multicast address. That's why you fill in with all the zero here. So, and there are some other different numbers too. So, but most likely you when you deal with the router, the neighbor discovery, you're going to see 3333 either with this IP address, with this hex number, or with the 3333 FF address. Okay. All right, let's move this on the side. So we just talk about the link local scope, old note. So this is FF02::1. And the other one we use a lot is actually using the one with the 104-bit, using the FF02::1, and then with the ::FF, and then the 24-bit of the address. So that's the other one you will see in the neighbor solicitation packet. And the important thing for you to know is the link local, both the link local, O note and O router here. O router is 2. And the EUI64, we actually disable by default now because of the privacy issues that's been raised using all the MAC address and split the first 24-bit and last 24-bit and put a FE in between. To form your 64-bit host ID number. I kind of link the IPv6 to the IP layer 2 MAC address, and that has raised some of the privacy and security issues. That's why it's been default by disabled by Microsoft Windows and a lot of Linux boxes. Okay. Okay, so this is UI64. Now the mapping of this, and see here is that you're going to use the, we already discussed that. I'd rather show you the real thing and then discuss this first. So you can see the 3333 here. This is the MAC address in the layer 2 multicast. And then, you know, it's a 48-bit, 48-bit, and so this is 32-bit here, 32. So this, the last 32-bit of IPv6 multicast address, it will be sticking to after the 3333 as so this is IPv6 multicast address, and you're going to copy that into the MAC address. So that is how we achieved without bothering every single one of the node and use the multicast address to communicate and get the MAC address that we want in the neighbor solicitation context, of course. And so, of course, you can see that for this, if we use the FF02 for the whole node, like a router, the router solicitation in there, then of course, you're going to copy the rest of the 32-bit here, and it will be something like this, okay? And then if we use neighbor solicitation, then you will copy this 32-bit address, including the FF in here. So therefore, you would multicast address will be 33. I didn't write it here. Yeah, that's 3333, and then this will be that. So I show you the real capture, and also this is a router solicitation and router advertisement packet you can see, and this is a neighbor solicitation and neighbor advertisement. You can see this kind of multicast address, okay? And I believe that is the end of the important information I want you to get. Okay, so you can enjoy reading the rest of the information, and we are going to jump to another document. We're going to focus on the neighbor discovery and M flag and O flag, the importance of that, the stateful and stateless information. Next document, we are going to download it. Actually, I already downloaded it for the router advertisement. So the document is called IPv6 Neighbor Discovery Router Advertisement Flags. So this is an important focus put on the router advertisement. You will listen to the router's advertisement packet in order to either get a stateful address from your DHCP server, or you will just get the stateless, so-called stateless SLAAC, stateless address assignment. So you go by yourself because you are either your A bit is not set or your M bit is set to the 0. So if you, the important thing you are going to look at is this M bit. Management bit. If the management bit is on, the client will use the DHCPv6 to get a stateful IPv6 address from a DHCP server. If it's not set, then even if you have a DHCP server, you won't get it. Even if you get it, then you cannot ping out. It's just something is not, you're kind of self-configured into a /128, and it can't even communicate with others, okay? So that's what usually confuses most of the newcomers for the IPv6 with the DHCP setup. Now the O flag set up the options, the other configurations. If your case, let's look at the case here. If M0O0, then the client uses the RA. RA usually have the prefix of the non-link local, such as a global address, like 2001:10:/64. That is the prefix. So then if you have an RA packet, which is M0O and 0, then even if you have DHCP server there, they will ignore it. Your client is going to self-generate and 2001:10::, and then with all the other self-generated 64-bit host ID. And so it's called stateless. And for the M=1, then you will listen to a DHCP and you would take the DNS server has been set up for, and everything will be under management. If M=1, and we don't care about O. If M0 O=1, then client will ignore all the DHCPv6. However, it will just take the other information such as the DNS into consideration. So very importantly, when you deploy that, make sure you set your M=1, and there's IPv6 vulnerabilities that we will do the exercise later on, just because the priority has been set low in your M flag, in your router advertisement, so that we use Kali to actually inject it router advertisement packet and send it to the high priority. So then it's served like a person in the middle, MITM attack. And it's not really an attack. Well, it is an attack, but it's also follow the protocol rule, so that your system, instead of go to your router to go out, it's going to go to the Kali and then go out. And of course, we mitigate it by using the switch security to say, hey, you cannot put the router advertisement packet through this particular port because you are not a router. Okay, so this is when we deploy IPv6, make sure we actually configure our switch port correctly with all the security. Sometimes they call it RA guard, okay, a router advertisement guard, to guard against a rogue router RA packet. Okay, and we will have exercise for that. And this is the packet of those flags. And let me show you the router advertisement packet that we have in here, the one that we just saw. Let me move it back. And let's move back here. And you can see that this is a router advertisement. And if you open it up, and you will see there's a flag in here. So you can see the router advertisement, and if you look at in the IP layer, in the flag here, and you can see that, hey, management is 0, and other is also 0. So that is where we find the flag on that, and you can see the prefix. The prefix information is 2001:1. So this is for the internal network. This is the router advertisement sent by the Windows 2016 in the exercise that we performed last week or a couple of weeks ago on that. And of course, later on, we changed that to M equals 1, O equals 1, so that everything will function smoothly. So at the end of this particular document, talk about RA. Sometimes we have routers here we already configured to IPv6. Make sure you suppress the RA, so then it wouldn't accidentally create a different routing or even a routing loop, so that it would disable your other network. And this is of course not the same as the mitigation to do the rogue IPv6 router attack by the Kali Linux. All right, so this finished the discussion of the IPv6 basic structure and multicast address, broadcast address, not broadcast address, I mean the old node address in the IPv6, and the relationship between the IPv6 multicast address and the layer 2 multicast layer 2 address, which is 3333, and the layer 2 is 3333, and then the 32-bit, it will be a copy directly from an IPv6 multicast address. That's very important, we remember that. And then don't be confused that with the IPv6, such as the neighbor solicitation, that we are going to solicitate the destination host with the FF 02 and then colon 1, and then we put an FF at the end, and then with the 24-bit of the destination host that we wanted to talk to, their IP address, we'll put it in there as the layer 3 multicast. Okay. And now we are going to really capture those packets so that you can actually getting more comfortable about what we have just concluded, and I'll show you the detail in there. And now, so we are going to show you how to capture the NS, neighbor solicitation, neighbor advertisement, and also the router solicitation and router advertisement packet. So we are going to, like what we did before, go to your ASAV without a VPN and just right click and go to snapshot and working live and activate that. And also go to your Windows 2016 and power it on. Um, and then we are going to configure the IP addresses according to this DSCP exercise here. I will put this topology up online into your IPv6 folder as well. But basically what we want to do is to show you how to capture those packets that we mentioned between the Windows 2016 here and the ASAV here. Structure is the same, 2001:10:10/64 and FEA0:10:64 for the link local and IPv6 outside. In this particular discussion and demonstration, we are not going to do the internal one. Now we're going to just enable the outside and give it an IP address of 2001:10:1/64, and then do try to find the capture the neighbor solicitation packet, and also enable the router advertisement from the ASAV and capture it. Okay, so. And the syntax, of course, I will put it up there as well. Let me just bring it down. Okay, so when we go to the Windows 2016, you're going to make sure your IP address is being configured correctly. Come here, and we have done this a few times. Go to change the adapter settings, make sure that is the case. So we already changed it. And look at the insights disable, which is perfectly fine for this particular exercise. And leave the V4 address, which is 2016 actually is at the 10.10.10.16, and we are going to SSH into the ASAV to copy paste some of the commands. In the IPv6, we use static, and which is 2001:10:2. And I mentioned that in this exercise, we're going to make it 1, right? And the default gateway is actually FEA0:10. So that is for this particular portion of the exercise. The FEA0:10 is the IP address of, let's see, let's see if I can bring it up here. Yeah. So you can see that we are going to, this is the syntax. It will be put it out to for you to associate it with this particular video, is that we configured that IP address of this GI00 the outside into here, into the 2001:10:10, and use FEA0, which is the 2016's default gateway. Okay, and then we suppress it, so the RA is not going to be available. We are going to eliminate that for now, and later on, we are going to don't suppress the RA, and then see if what is the M flag and O flag, and then we're going to turn on the M flag, O flag, and capture it again. Okay, so we're going to put this on the side, and so you see that this is the 2016's IP address, the 2001:10:1, and then the FEA0:10, which is the ASAV, serve as the default gateway of this Windows 2016. All right, say okay on that, and let's get out of here. And now we're going to SSH into the box. So 2016, make sure I am on the 2016, and putty is here, and that's why 10.10.10.53, that's the one I want. And you're going to say yes, even though you don't trust that certificate, even though it's not a trusted, meaning that it's a private certificate. So Cisco password, and enable has no password. Now we are ready to bring this document up, and say, hey, I want to configure it now. Where's the IPv6 address? So you're going to copy, and you're going to come here and right click. Okay, it's already pasted in. So now it is with this IP address of 2001:10:10. Link local is much easier using FEA0:10. So it's both at the end of the 10. All right, so this part is done. Let's see if we can ping it now. Before we ping that, let's do this Wireshark. And what we will do is we are going to actually select. Okay, let me make sure I got this one up. And capture. And I think we have no interface to choose, so it will just work. Now let's reduce it. And we are going to go to command prompt. So we're going to ping 2001:10:10. That's our ASA. So now it's working fine. Let's go to our Wireshark and let's bring it up a little bit. And then let's just stop the capture. And you can put in the filter, ICMP v6. And you can see that your link local address of the Windows 2016, it tried to find, do a neighbor solicitation to find, hey, do you have router advertisement? I want to talk to you. But the router, remember, we asked them to suppress. So it's not going to talk back. You're not going to see the router advertisement. So we see just a neighbor solicitation. Again, we are going to skip theirs. We're going to just focus on the 2001 neighbor solicitation here. So the first neighbor solicitation we are looking at is, all right, your 2001:10:1, the Windows 2016, the outside interface want to talk to the interface of the router, which is at the 10. So we see that the multicast address of that is the last 24-bit of the 2001:10:10. So therefore, of course, it's 00010 here. And then, so this is the multicast address. And of course, the 32-bit here is going to copy towards here as the multicast address on that, as the router, as the neighbor solicitation. And the advertisement, then it's a unicast back. Your router, your neighbor here telling you that, let's take a look at the advertisement back here. This is the one that we want to see. The 1010 that we want to ping actually come back to you and using the true MAC address they have here, unicast back, and tell you that, hey, I am here at this MAC address. So this is the associated neighbor solicitation, and this is the neighbor advertisement. Okay, and the importance of that is you can see that in the neighbor solicitation, you are using the solicited multicast IPv6 address, and with the multicast layer 2 MAC address to do the multicast, not the broadcast. That's the major improvement too in IPv6 over the OP protocol. Right now, we are going to actually continue on to capture the router advertisement. And okay, so if you do the NASH interface IPv6, you show the neighbor. Now you can see that both the 2001:10:10 and the FEA0:10:10 here, both the global and the link local address of the router has the same MAC address already being cached in. Okay. All right. So now we are going to copy and paste in this part. and go back to your SSH. And we paste that in now. Okay, so you can actually, once we copy and paste the command to the ASAV for it to start to put out, spit out the router advertisement here. And you can see that the router advertisement is going to the O note to everyone. And you can see the flag is M0O0, okay? And if you look at the layer 3 information is FF02:1, then of course, then the multicast address will be 3333, and then with the 32-bit being copied from the destination here. So that's the router advertisement there. So we're going to stop the capture here, and we are going to restart the capture here. Okay, so what we will do is then we are going to make it we're going to copy we're going to make the management flag and O flag to become one. Okay, copy, and then we come here. Party is gone, so we can actually restart the party. Log in as Cisco. Okay, enable, and no password, and just right click. We have to config T, I believe. Let me just copy it again. Copy. Oops. Let me just type in a few. Kind of messed up a little bit. It's already in config T. So, oh, I made a mistake here. INT, probably accidentally push a lot of in here. That's actually interface, right? All right. Copy. So make sure when you copy paste it in, you watch for the error message. Okay, so that's been inputted into the ASA router security appliances, and let's take a look at the Wireshark, and then let's capture it. We'll start the capture. Okay, so after waiting for about 10-15 seconds, then you can see that the router advertisement has been sent out from the ASAV with the N flag turned on and other flag also turned on. Okay, so this concluded our discussion for the neighbor discovery. We covered the neighbor solicitation, neighbor advertisement, and router solicitation and router advertisement. And you can see the multicast address and the layer 2 multicast address. So that is the basic foundation for us to understand IPv6 network implementation in and out. And also we'll watch out for some of those security issues that's related with these issues. And we'll do more recordings in a few weeks related to the rogue IPv6 router. Okay, bye-bye.